Good morning, everyone.
Good morning.
First of all, thank you so very much for coming over. It's a great pleasure to see everyone taking time out on a Saturday morning and coming over to discuss, debate, learn together, etc. Thanks a lot to Bhaskar and Analytics India magazine. I have a long relationship with Bhaskar and Analytics India magazine. It's a very happy relationship, and all of us, when we started our careers in analytics, there were a handful of maybe 1,000, 2,000 people working in this, and people like Bhaskar really helped us create a community among ourselves, because we were a minuscule set of people working among accountants, IT professionals, etc., and we didn't have an identity of ourselves. So thanks a lot to Bhaskar and Analytics India magazine for giving us sort of an identity. So first of all, before I start the session, I wanted to share a few things. So whenever I get the opportunity to talk to people like all of you, it's a great opportunity for shared learning. And why I really look forward to these sessions is to learn from each one of you. And that's sort of a collective learning which draws me to some of this. So we will make it sort of an interactive session rather than just me speaking anything. So if you have any points, observations, differences, any views, please don't hold them. Bring them up, and we have time to discuss all that. And if time doesn't permit, we obviously have time after that, and then over chat, LinkedIn, etc., etc. Okay. So here it is. Many of you saw this slide, but I'll still repeat it a little bit. So all of you say that data science or machine learning is a very new discipline, which is very new. Came up in the last 5 years, 10 years. However, do you know who was the first data scientist in the world? This is actually this gentleman, and you saw his name as well, because it was not in presentation mode. So, who is this person? No, this is not Socrates. This person lived even before Socrates. Yeah, this person is Thales. So one thing that Thales did, all of us knew in school, was, all of you read in geometry, right? That the sum of the two sides of a triangle is greater than the third side. This theorem is out of him. So he is considered the first data scientist. And why is he considered the first data scientist? He's considered the first data scientist because what he did about 2,500 years ago, he used something which in our world today we call time series forecasting. He used that to forecast demand for olive oil in ancient Greece. And then what he did was, based on his forecast, he could forecast the prices of olive oil is going to go up. And therefore, he took all the olive oil presses on rent, using something that we call in our world as option pricing. And then he became very rich. And this is one of his disciples. How do we control this? This is one of his disciples. Aristotle spoke about him. Thus, he showed the world that philosophers can easily be rich if they like, but their ambition is of another sort. So in those days, all science was philosophy. So that's the whole idea of data science. It's a science with numbers which help us make money. That's essentially, you can distill everything in just that one brief sentence. Now, just give me 1 second, I have to see how I can navigate this thing a little better. Okay, now this is something more closer to our times. The first neural network in the world, when it was implemented, not even the theory created, 1959 at AT&T, where it was used to filter out noise from telecom networks. The first company which used analytics and data science to make money, way back in 1956, is a company which still today exists, called Fair Isaac, started by these two gentlemen, Bill Fair and Earl Isaac, where they used the power of analytics to help simple auto dealers make decisions about whom to lend and whom not to lend. We all talk about recommender systems, right? We all talk about Amazon. I mean, we all know it every day. The first recommender system was built way back in 1992 for Netflix to sort of provide movie recommendations. So data science and the application of data is not as new as it is sometimes thought to be. However, what is new is, because today, due to the democratization of technology, due to the ability to capture more and varied types of data, the prevalence and the usage of data science has become significantly more widespread than it was 10, 15, 20, 50 years back. However, the concepts that we use, the ideas that we use, are all 30, 40, 50 years old. Now, so therefore, what do we try to, or what's the objective that we try to do in data science? So essentially, we try to do this three objective, and this is important because if we are, because one of the things that we wanted to discuss today was how to shift one's career to something to do with data science. So in order to shift our careers to data science, it's important that we understand what data science is, right? Then we know where I'm shifting. We know it better. So that's the objective. Then we will come to what it takes to make the shift. And this is a simple analogy. So essentially, data science just means this. Let's look at this room. Let's make so say I look at everyone in this room and I look at the income of everyone in this room. And looking at the income of everyone in this room, I come up with a simple rule. So the simple rule is everyone wearing a blue jeans is rich. Okay? Let's just assume that I look at the income of all of us in this room and I come up with a simple formula, everyone with a blue jeans is rich. Okay? Now, after 5 minutes, someone else walks in. I look at his or her color of jeans, and based on that, I infer whether that person is rich or not. So that's all what data science is about. So what we first do is we use data to create a set of rules. Now those rules can be very complex models. They can be as simple rules as anyone with a blue jeans is rich. So we use data to understand that rules, and then we apply that rule on data. So next time someone walks in, that person is giving me a data. I'm looking at the color of the jeans of that person, and if the color of the jeans is blue, I infer that that person is rich. So therefore, what data science involves is first data. So data is almost our raw material. It's the oxygen. Without data, none of this exists. AI, machine learning, data science, whatever we call it. If we don't have data, we don't exist. So data is our food, our raw material, our oxygen, whatever we call it. That's the building block that we start everything from. So that's sort of our raw material. Using the raw material, I try to extract an intelligence, a rule, a pattern, a model. Okay? We may call it in various names, but at the end of the day, it's a generalization of a rule extracted out of the data. And that rule can be called a machine learning model, say a deep learning model. It can be called a simple if-then-else rule. For example, if a person's color of jeans is blue, then that person is rich. So culling out this rules out of the data, that sort of is our second step. And the third step is implementing that within our business. What that means, think of it, I'm trying to, and you can make things, even with the simple rule of blue jeans, quite complex. Now, someone else walks in. I don't have a human being looking at the color of the jeans. I need something, I need some technology to look at the picture of the person who's walking in next understand his or her jeans color. First of all, whether he or she is wearing a jeans. If yes, what is the color of the jeans? And then see if the color is blue, then that person is rich, therefore offer him Mercedes or something. Okay? So that's the whole idea. So data science involves these three basic steps. We start with data, any form of data, that's always our starting point. If there is no data, we don't have a play. We need data. We need something to extract that. Okay? So with this, we will go into a little bit what is needed to become a good or a successful data scientist. Now, one interesting thing about this whole discipline called data science is, by definition, it is very multidisciplinary in nature. I will give you a very simple example. I do not know if I have a white marker. I do have one. This is a simple problem which you must have seen all of us have seen in our high school. Say I have a rectangle, okay, whose sides are A and B. Okay? Now, if I want a given perimeter of the rectangle, so A plus B is equal to constant, okay? What should be the proportion of the sides so that the area is maximum? We all know the answer, right? A simple problem to start the day. So if your area has to be constant and you have a rectangle, what should be the final rectangle that will maximize area? We all know it's a square, right? It's a square because, well, some bit of basic maths to start with. So A and the other is K minus A. So if you do, so you have A minus A square. And if you maximize it, you will have K minus 2A equal to 0. So A equals to K by 2. So what that means is, if you have various skills, for example, if you are very good at maths, but you are very bad at programming, you can't be a good data scientist. But if you are slightly average at maths and slightly average at programming, you are much better than a person who is excellent at one and absolutely zero at something else. Because data science, by definition, is a very multidisciplinary skill. However, one sort of disclaimer at this point. So in the next slide, I'll talk a little bit about what we need to do to become successful in a data science role in organizations. Now, when I say that, I mean organizations like banks, retail companies, manufacturing companies, logistics companies, etc. I do not mean very high-end R&D teams, for example, R&D teams of Google or R&D teams of Microsoft or maybe R&D teams of Boeing, where you possibly need people who are very, very good in one dimension and doesn't matter for anything else. In my discussion, I will talk about data science in context to most business organizations. So that's a disclaimer. So with this, I'll look at what we need to become a successful data scientist. Now, as I said, by definition, we in the data science profession need to be a little bit multi-skilled. And it's better that we have multiple things in some proportion rather than having zero of anything. Obviously, if you are best at everything, nothing like it. So, obviously, it's difficult for everyone to have every possible skills, but these are some of the skills which are critical to be successful in a data science career. The first, of course, is understanding of quantitative methods, mathematics, statistics, operations research. One has to understand the maths, and that's important because at the end of it, what we are trying to do is to generalize these rules, patterns, and models out of the data. And that generalization is done through mathematics. So mathematics and statistics and operations research are disciplines which helps us build those rules, models, etc. And we have to understand that, because if we do not understand that, today many of our junior members, even senior members of our community think that we can sort of click and download any sort of algorithm from the net and apply that very easily. But if we do not understand, at least to some extent, how it works, it's very difficult to understand its limitation, to understand where it can be used, more importantly, where it can't be used. So an understanding of maths, stats, OR is important. And at least if you do not understand maths, stats, OR in terms of alpha, beta, gamma, you at least need to understand it from an intuitive perspective. For example, when you talk about regression, what is it intuitively doing? When you talk about neural network, intuitively what it is doing. When you talk about random forest, intuitively what a random forest is. Intuitively what is clustering. At least that understanding is very, very important. We can't say that we don't at least understand it intuitively and then become a data scientist. That's just not possible. We may not understand all the intricate maths behind it, but some appreciation of the maths is very, very important. The next is understand algorithm. Maths and algorithm may be slightly different, and I will tell you why. Now, you may understand the maths behind what is a regression. Everyone does. You fit a line between many, many points and you find out what is the best line. We understand that. But we will not be plotting points on a graph and fitting a line between them. We will use the computer to do it. Okay? And the computer will use some sort of an algorithm to solve the problem. So the method or the algorithm that the computer is using to solve the problem is important to understand, because, for instance, the time that it will be taken for the computer to come to the solution is dependent on the algorithm. So some understanding of the algorithm is important, particularly because though computational power is increasing every day, but our data sizes are also increasing every day, and many of the use cases of data science that are coming up requires our maths to be applied at a very, very quick pace. Therefore, understanding of algorithms, for example, things like search, things like branch and bound algorithms, things like hill climbing algorithm, etc. How you are finding the solution to the maths, how you are implementing the maths. At least intuitively one needs to understand that. The third one, and this is absolutely critical, which many of us sometime or often overlook, which is understanding the business context. Now, the business context is so very important because many a times what happens is you may end up building a fantastic model, or you may build a fantastic data management framework. But if we do not understand how it will be used by a particular business to make money, then whatever we have done is completely futile. Completely futile without understanding the business context. So understanding the business or how this thing will be used by a sales head or a finance head or an operations head or a logistics head in an organization, that is extremely important. I mean, I can tell you stories after stories where we have built some of the most successful, most highly predictive models, but they have been completely thrown out of the window by business managers because we have not completely understood the business context while building it. And I can share a few stories about it. Let me share one quick story on this. So once we were working with a big credit card issuer in the US, and we were using things that retailers use to predict what will be your next purchase. For example, if you book a hotel, the next thing you will possibly ride on a taxi. And so we built models which were very highly predictive, working all good. We were very happy about that. Now, then we went to the business head and said that we have done this great thing and we were extremely happy about it. So what he said is, what's the use of it? How will I use it? He said, why won't you use it? As soon as the hotel transaction is done, you send him an SMS or you print it in the charge slip that comes out of the machine and say that you have 5% off on a taxi. He said, but if the guy is anyway taking a taxi, why will I give him 5% off? Then I'm just killing my own business. You don't even understand this. So it's very, very important to understand the business context. How will you make money? Because at the end of the day, whatever we do, our end objective is to make money.